There we go. Good morning. We're almost done. Isn't that exciting? We're going to talk about 11.3 today, and then so send me a picture of your homework after we finish talking about that today. And then I sent out on the Walker Web, the news thing today, it talked about not having a session on Monday. So we will not have a Zoom session on Monday. You have nothing new to work on between now and Monday, which is good. And so on Monday, I'm just going to send you out a Google form, kind of like assessment quiz that will just cover 11.1 and 11.2. So area of a sector and arc length. Okay, it will not cover 11.3 on Monday. So on Monday, you'll get a same little news bulletin on the Walker Web. It'll just say check your email and complete that Google form on Monday. Okay, I won't assign 11.4, and that won't be due until later on next week. Okay, so no session on Monday, just working on that Google. It'll be good. Nothing to do over the weekend. I mean, I have the notes if you want to work on them for 11.4, but they're not due until Thursday of next week. Okay, and so make sure you send me a picture of your 11 homework at some point today. Okay. All right. So what I posted the notes, the key to the notes online last night. Do we have any questions about the notes themselves to cover? And if you haven't had a chance to go look at those, the key to the notes, make sure you go and do that so that your notes correspond to those. Okay. Do we have any notes about finding the area of all these regular polygons inscribed in a circle? Off the notes, like any of the concepts themselves. All right. Okay. All right. So what questions homework?
Could we go over number 19 and 23?
19 and 23. Okay.
Also number 20 and 21.
Okay. So I have 19, 21, and 23. Anything else? All right. If it comes up, just shout out. We'll go over it. All right. This is my coffee maker. All right. Let me go ahead and share my screen here. Okay. So flip so you see my forehead. Okay. All right, so 19, 20, and 21. So for all three of these, I'm going to use the bottom portion to work them out, and then I'll have to erase it. So if you need to copy it down, I'll try to just tell me to slow down before I. So find the perimeter and the area of the regular. So before we do that, guys, remember from the notes to find of a regular polygon inscribed in a circle, the formula was the area of that polygon, regular polygon, is equal to 1/2, A is the apothem, times the perimeter. Okay, so you have to find the perimeter anyway to find the area. So it kind of makes sense they're asking you for both of those. So for 19, first off, you have to count the number of sides that you have. So we have 1, 2, 3, 4, 5, 6, 7, 8 sides. So it's an octagon. So regular octagon. Okay, so 8 sides. So the first thing we are given, like if the circle drawn around the octagon, this 20 would actually be your radius. So what we need to figure out is we have to find the apothem, and then we have to find the side length. We have to know those two things, okay? Knowing that the radius is 20 is going to be helpful. So we know the radius is 20. So from the notes, in every radius to a vertex, that would give us 8 central angles. So in order to find the measure of one central angle, I do 360 if I were, because it's a complete circle around that, divided by 8. Okay, and then what is 360 divided by 8? Should get 45 degrees for each of those central angles. Okay, just one central angle. You're going to see my forehead here. I'm going to draw in the apothem, and then that's going to create a right triangle. Okay, so if you remember from the notes, when you draw in, so here's my 20. When you draw in the apothem, cut that central angle in half. So this angle right here is going to be 22.5 degrees, which is half of 45. Okay, so from here, guys, you're just going to use right triangle trig to figure out. So I need to find, this is the apothem, right? And this is going to be, I'll call this x. Okay, and then I find this is actually half of my side length here. Okay, so this would be my apothem, and this is actually half of a side length. All right, so what I'm going to do first, I'm going to just say here at this angle here, 22.5, and I'm going to solve for, what did I do first? The apothem here. So I'm going to use, this is the adjacent side here for the apothem over 20. So cosine of 22.5 degrees is equal to the adjacent side, which is the apothem, over 20. And then to solve, you just multiply both sides by 20. And the apothem is approximately, I got 18.5 approximately. A little off. A lot of this is rounding, guys. So that's okay. So this is my apothem, which I needed to know right here for the area. The last thing I need to do, I can use the formula, is I have to find the half of the side length. So this would actually be your opposite side. So I'm going to use the sine instead of the cosine, still at 22.5, is equal to half that side length over 20. And then multiply both sides by 20. And then you have x is approximately 7.65. You have to remember that's half a side length. So to find one full side length, I have to take this number, 7.65, and times it by 2 to get a side length. And that's approximately 15.31. Okay, all right, so I have a side length. I'm gonna erase this formula here. Okay, so I have the apothem. It's 18.5. So to use that formula, I have to know the perimeter. So if each side is 15.31, you have 8 sides, you have to multiply to find the perimeter. You have to take 0.1 and times it by 8 to get the perimeter. And you get approximately, what did I get here? Perimeter 122.48. Like I say, your numbers might be a little bit different depending on how you round it. If you're close to my number, you're good to go. So I have the apothem, I have the perimeter. So now I can use the area formula, 1/2 times the apothem times the perimeter. You get the area is approximately, kind of a large number, 1,132. Problem was kind of long. A lot of these problems were a little long. All right, any questions about that? You actually had to use right triangle trig. You could at this point, instead of using 2 trig functions, you could at this point right here when I did the sine, you could have actually done Pythagorean theorem if you wanted to. All right, is that okay? Need another second? Good.
Wait, so for 21,
I'm gonna get to that, Shira. I'm gonna do that one.
oh, I didn't realize that. Oh,
Yeah, I'm
okay.
gonna do 20 and 21 actually. All right, well, I am recording, so if you need to go back and freeze it on this part, you can. Okay, so let's do 20. All right, so they're all very similar problems, guys, but it's just they're giving you different information. So in number 20, you're actually given the apothem is 4.1. Okay, we have 1, 2, 3, 4, 5 sides, so it's a pentagon. My page here. Okay, so if you have a pencil, find a central angle before we can get started. So a central angle, we're going to take 360 divided by 5 sides. That's going to give us one angle, and that would be 72 degrees. All right, so if I were to, here's my right triangle here. Remember, once you draw on the apothem, it actually cuts that central angle in half. So this angle is half of 72, so it's going to be 36 degrees. All right, so to find the perimeter and the area, I have to know, let's see here. I don't think I need to know. I need to know this side here. I need to know. Once I have the apothem, you're good. I don't have the hypotenuse of this triangle, which would be a radius. Okay, so I actually just need to find x. X would be half a side length. Once I have that, double it and go from there. All right, so if I'm at 36 degrees and I need to know x, it's going to be opposite over adjacent. If you guys remember from right triangle trig, that is tangent. So tangent of 36 is equal to your opposite side over 4.1. And then you just multiply both sides by 4.1. Half a side length is about 2.98. And it's not telling you guys how or how many decimal places to round. So if you said, if you said 3 or something like that, your number might be a little bit different than mine, but it's close enough and that's okay. Okay? All right, so to find a full side length, I take 2.98 and times it by 2. And 5.96 for each side. And that's going to help find the perimeter. Change colors here. Let's not do that color. All right, so the perimeter is going to be equal to 5.96, the number of sides I have, so times 5. That's going to give me 29.8 about units for the perimeter. And so once you find the perimeter, and we already know the apothem, we can use the formula to find the area. So A is the apothem, P is the perimeter. And I just plug it in, and you should get about 61.1 about. Like your number might be a little different, but that's okay. As long as it's pretty similar, units squared. So here's your perimeter, here's your area. So that one wasn't quite as long. Number 19 was pretty long. All right, any questions about before we go to 21? And when I have my tablet down like this, I can't see a chat. So if you're trying to send me a message, I can't see it. So. All right, so that was 20. Let's do 21. Okay. So 21. So here, what do we have here? What do we have in 21? We have 7 sides, right? So this is a heptagon, so 7 sides. And I'm given that a side length is 9. So that's actually going to give me, I'm going to be able to find my perimeter really fast. So if I have a side length of 9, I can easily find my perimeter. So side length of 9 times 7 sides gives me 63 units. So I have the perimeter. I was able to answer pretty fast. The area. So to find the area, I need to know the apothem. So I already have the perimeter, just have to find the apothem. So if I know it has 7 sides, I need to know the angle. I'm just going to circle that because I have the answer to that. So a central angle is 360 divided by 7. And that's going to give me about 1.42 degrees. So if I want to go ahead and draw a right triangle. Remember, I'm drawing the apothem. So here's my center. Once I draw on the apothem, it actually cuts this central angle in half. And right here is going to be half of 51.42, which is about 25.71, approximately. Okay? All right. So what I need to know is I need to know x. X is the apothem. But I do know that a side length is 9, so half of that would be 4.5. Because when you draw in the apothem here, it actually cuts this side in half. All right, I have to figure out the apothem, so I'm at this angle here. I'm going to use 25.71. So I have opposite and adjacent. So once again, I'm going to use tangent of 25.71 is equal to side over x. So remember, guys, from right to a two-stepper. So I can't just multiply both 4.5 because 4.5 is already in the numerator. So first, I got to multiply both sides by x to get x out of the denominator. Okay, and then have x times the tangent of 25.71 equals 4.5. So now to get x by itself, I have to divide both sides by tangent of 25.7. And then I just plug it into my calculator. X is approximately, what did I get? 9.35. So that's my apothem. All right, so now that I have that and I have the perimeter, I can easily find my then 63 for my area is approximately 294.5 units. Okay. Any questions on 21? Shout out, guys.
No, I'm good.
Okay. All right, let's go on to 23. All right, so 23, 24, and 25 are all very similar. They just kind of gave you some different information. You had to say, okay, what do I need? What links do I need to know in order to find the area of that regular polygon? So in number 20, you're actually given the radius. So what you need to figure out is that you need to know the apothem, and you have to know a side length. So that's the information that you need to know to find the area. Okay, so we're given, this is actually a square, which that's obvious, okay? So I draw in the apothem, I kind of drew it flippity-flop. I have this, so each angle, a central angle for here, because we have 4 sides, So central angle is equal to 3 divided by 4. Each central angle would be 90 degrees. Okay, so if I draw my right triangle here that I drew in the picture, okay, I know that the hypotenuse is 14 because that's my radius, okay? And I know this angle at the bottom, it cuts that central angle in half, so this is 45 degrees, which would make this 45 degrees, okay? All right, so what you could do from here, you could use right triangle, okay? Or you could use your special right triangle. This is a 45, 45. So no, these two sides are exactly the same. These are my legs of my isosceles right triangle. You remember, I'm going to use my special right triangle pattern. I know that in a 45, 45, 90, the hypotenuse is x square root of 2. So it's a leg value multiplied by the square root of 2. So to get x, I would just divide by the square root of 2. And then you can just put that in your calculator, guys. You don't have to do it as a fraction or anything like that. And you should get about, once you do that, you get 9.9 approximately. Then into your calculator. 14 divided by the square root of 2. So I have the apothem of 9.9, because that's this length right here. This length over here is actually a half of side length. Okay. So if you multiply it, 0.9 times 2, you're going to get a full side length of 19.8. Okay. All right. The side length, each one of these sides is 19.8. To find the perimeter, which I need to use the formula, I'm going to do the perimeter is equal to 19.8 times 4 sides. And that should give you about 79.2 units. All right, so once I have the perimeter, I have the apothem, I am good to go to find the area. So 1/2, the apothem is 9.9 times 79.2. And you get the areas approximately, like I said, your number might be a little different, but as long as it's close to mine, good. And there's your area, 392.01 square. All right, any other of these problems I could go over? Like I said, number 24 and 25 are pretty similar to 23, just a slightly different. I think 24 and 25. 24 gives you, you actually end up with a 30, 60, 90 triangle when you draw it. So that's, you can use your special right triangle for that. And then in 25, you could either use trig, or you can use the Pythagorean theorem to figure out what you need for that. All right. Those problems are not short. Depending on what you're given, it might take you a minute, but I like this section of the chapter because it actually brings in some of our right triangle trig stuff that we did a while ago. So it's good. Remember SOHCAHTOA and how to do the Pythagorean theorem and that little formula for the area of a regular polygon, and you got it. Do we have any other questions or anything I can help with before? Guys, want to stick around if you have more questions. You can stick around and go over anything that you need. As far as anything else, guys, make sure we covered a lot today. If you need to, I'll post this video as soon as I can once it uploads and all that. So if you need to go back and look at those problems that I worked out, if it was a little fast, go ahead and do that. And just send me a picture of your homework by the end of today. Okay? Yeah. And then you can just enjoy your weekend and look out for that Google form on Monday. So no Zoom session on Monday, just working on that Google form during this class time, okay?
Okay.
All right, guys.
Should we?
Okay. All right. Shira, you want to go over some more?
Should we work on 11.4?
if you want to, darling, like you don't have to. It's not due until Thursday of next week. But if you want to go ahead and start, you can, or if you just want to kind of chill out and wait for that Google form on Monday, it's completely up to you.
Okay. Thanks.
Yeah, because 11.4 won't be due until Thursday.
Okay. Thank you.
Okay? Okay.
Yep.
Okay. Anybody else have anything they want me to cover? Good?
Thank you.
All right, guys. Have an awesome day. I will talk to you next week.
Bye.
Okay.
Thank you.
Bye.
Thank you.